Explain ACID properties in context of SQL databases. ACID is an acronym stands for atomicity, consistency, isolation, and durability. These are a set of properties that ensures the reliability and integrity of transaction in SQL databases. Atomicity. Atomicity guarantees that a transaction is treated as a single individual unit of work. Either the entire transaction is executed or none of it is. There is no partial execution. If any part of transaction fails, example due to an error or an exception, the entire transaction is rolled back, ensuring the database remains in consistent state. Consistency. Consistency ensures that a transaction brings the database from one consistent state to another. In other words, the database must meet a set of integrity constraints and rules before and after transaction. If a transaction violates any integrity constraints, the database management system will prevent the transaction from being committed, and any changes made by transaction are undone. Isolation. Isolation ensures that concurrent transactions do not interfere with each other. It prevents one transaction from seeing the intermediate uncommitted changes from another transaction. Isolation levels such as read uncommitted, read committed, repeatable read, and serializable defines the degree to which the transactions are isolated from each other. A higher isolation level offers stronger guarantee but can lead to performance trade-off. Durability. Durability guarantees that once a transaction is committed, its effects are permanent and will survive any subsequent system failure, such as power outage or crashes. To ensure durability, the DBMS typically writes the transaction changes to non-violent volatile storage, example hard drive, and record a log of changes. In the event of a failure, the database can use the log to recover the database to its last consistent state. The ACID properties are critical for maintaining the data consistency and readability in relational database. They are particularly important for the system where data integrity and accuracy are paramount, such as financial application, e-commerce platform, and system where data consistency is crucial. It's worth noting that enforcing ACID properties can sometimes comes at the cost of performance, especially highly concurrent environment. As a result, NoSQL databases and some new SQL databases offer a different set of trade-offs that prioritize other factors such as scalability at the expense of some ACID properties. The choice of database system should align with the specific requirement of the application.